Good morning, everyone. Who likes K-pop? No? Yeah, my daughter's a big fan of New Jeans. And today's song, and first song was ASAP, which deals with two topics from today's lecture, temporality and regular expressions. So we'll get to go through both of those today. All right, so last lecture, I had the overly ambitious goal of trying to cover all of EDA in one lecture. I did not succeed. EDA is something we're going to cover throughout this class. So I'm going to try to wrap up quickly through the remaining key parts of EDA and then switch to this discussion about regular expressions and working with strings like ASAP. So we spent most of last lecture thinking about structure. This is how is the data formatted. We talked about different data formats, so tabular data. This is an easy place to start, CSV, TSV, spreadsheets, pulling from SQL. We talked about nested data and JSON. We looked at how data is organized, the records. Can we define a record? What's the granularity of them? Do we need to unnest or expand records if they're JSON? We talked about differences. Go through these right here. So we talked about pulling data from different sources. So joining and merging external data sources is a key part of EDA. When you realize you don't have all the data you need, how do you bring data in and how do you work with it? We talked a lot about fields at the end. So what is the type of data that we're working with? We talked about the storage type, like integer, float. And then we also talked about the conceptual type. And we had quantitative continuous, we had quantitative discrete. And then on this other side, we had these categorical things like qualitative ordinal and qualitative nominal. And those make for great questions, so you should review that material, make sure you're comfortable with that definition. And that'll also be very important as we get to data visualization. Understanding the data you have defines how you should visualize it. Okay, so this. Now, we talked a little about structure. We talked a lot about structure. We talked a little about granularity. I'm going to move on to scope and temporality. We'll talk about scope first, then temporality, and then there's a demo for faithfulness that I won't get to, but I'll just quickly highlight so that the key takeaways that you'll need for your homework. So scope, this is what does my data represent relative to the problem I'm trying to study? What is the population I'm interested in? This could be this circle up here. So maybe this population is not what my data, there's some overlap with my data, but there's some stuff that I didn't get sampled, and there's parts of my data that maybe I need to remove. Right? So this is a pretty standard situation where you have to understand the thing you're trying to study, what your data reflects about it, and where your data might be extraneous, unnecessary, outside of the scope of the population, and then the consequences of missing this part, this whole space over here of the population. Sometimes you're lucky and you're in a situation like this, where you get data that just covers everything, and you're interested in a little group inside of your data. It's a good situation to be in. You might have to do some filtering to get rid of all this stuff over here. But of course, the problem with filtering is, this could have been a sample from your population, so that filtering process might actually be, reducing your data significantly. So you filter it down and you find that you have, one piece of data from your population inside of it. Okay. So be careful with the filtering process. All right. The other big part about scope is not just does it have the right group of students or does it have the right customers, but also does it have the right time? And this is often overlooked because we get new data. It must be the right time, but the temporality of data actually matters quite a bit. And what does it mean to be time in data matters a lot. So let me explain that. So it gets to temporality. So data is a changing thing. I said this last time. Data is often documented. You should read the manual, but you shouldn't trust it, because as data changes, the manual becomes inaccurate. Likewise, the data itself, it might have said, this was student grades, but from what semester? Was it collected at the end of the semester, at the beginning of the semester? So understanding how the data was collected in time is important. We'll talk about space, but before we get there, periodicity. So when we think about time is kind of like a cycle. If we just look at a day, it goes around. You wake up in the morning, you do lots of stuff, and then you go to sleep. Maybe you're not active, and then you pop back up again in the next day, right? So we have this diurnal structure of time, which is like maybe day, night. And this was, let's say, activity. This could be activity, right? So you have to deal with these changes in time, And it matters because if you take data from the West Coast and data from the East Coast and you put them together, they're not actually all at the same time. So understanding the time that an event or piece of information in your data lives and how that reflects where the sun is during the day. So diurnal patterns. That, of course, depends on where. All right, so let's talk about the meaning of a time or date field. So you see a timestamp or a date in a row. What does that reflect? We often like to think that's when the purchase was made or when the transaction happened or when the patient arrived at the hospital. But it could have been when the nurse decided to enter it into the system, right? So it might have been a different time from the time you're actually trying to study. And then sometimes, annoyingly, it's when the database admin copied the data into into their system that they then dumped and handed you a nice CSV file from. So what does a timestamp mean? Worth thinking about. How would you know? You read the documentation. One thing to look for here in this category, and sometimes in this category too, but certainly here, is are all the timestamps the same? So everyone has exactly the same time. That never happens. Not all the patients arrive at the same time, right? So look at the timestamps. If there's a lot of clustering in it, might mean that they were, timestamps were created when the data was imported. This one's a little bit trickier. Understanding your documentation is important. Like they say, this is the nurse enters patient information once the patient has been checked in. Okay, so the actual entry time isn't when the patient arrived. So understanding the context. Sometimes you have to talk to people. So you have to actually ask questions. Can't write. Ask questions. Yeah, so a lot of what we do in data science will involve talking to other people. So get good at that. All right, so how do we work with this data? All right, one of the really useful tools is the date time library, which allows us to deal with things like time zones and transforming dates, pulling out the fields like the month, the day, the year, the day of the week, time of day, and so on. So figuring out how to deal with time zones is important, and there are tools for doing that. This is tricky. And then, of course, normalizing your data so that they're in some consistent time so you can do analysis. Okay. One other thing that it's funny, when I taught this class internationally, and people use different timestamps. So what day is that? Yeah. Is that July or August? Depends on where you are. And actually, the way that the Python libraries will run depends on the region that they're running it. So if you run your notebook with a different regional code in a different system, it'll interpret this differently. In the US, we typically treat this as the month. This is the day, and this is the year. Okay. We'll get more to unfaithful data, but another thing to look out for is dates like January 1st, 1970. January 1st, 1970 is a very important day. It's day 0 in Unix time. So computers all count time from that date. So if you have a 0 in a field and you say, make this into a date, that is the date you get right there. This slide used to say 1900 because I'm old. And so when I see 00, I assume that means 1900. But not that, yeah, you guys are post 2000. So if you see another date, maybe it's 00 in the year, means that they didn't incorporate the year. And so the date is sometime in 2000. So watch out for these kinds of misleading dates. Okay. Faithfulness. Last big topic. When you're looking at your data, you should be suspect that someone has messed with the data or it wasn't collected correctly. Common things to look for. If you have exactly 65,536 rows, something possibly is wrong. Very likely, this was export from Microsoft Excel, which only export that number of rows. So there could have been more data, but someone passed it through an Excel spreadsheet, and you lost some data. Same thing, 255 columns is a special number. If you see that number of columns, maybe you have a problem. This is just one example of the sort of things to look for. I would say, in general, when you see round numbers of anything, that's not that common. So investigate. So you see exactly 100 rows in your table. Maybe you have 100 students in your class, but it's worth checking that it wasn't some export error. All right, duplicate entries. So you often see duplicate columns. We'll come to regression, why this could be a problem. You might see duplicate rows trying to figure out if a student signed up for a section twice. These are the processing steps you want to work through. Having an idea how the data is organized and what you should see, important. And you'll use pandas operations to do these kinds of things. Spelling errors, and we'll talk more about that in a moment, are a pretty big problem, very common. So with spelling errors, people filling in forms like, what's your address? What's your state? You can type California, or just CA, or maybe I'll use lowercase California, or maybe I'll just misspell it. It makes it hard to cluster and analyze your data, and you need to deal with that before you go on to further analysis steps. So you can apply dictionaries, and we'll talk about process of simplifying your strings so that you can address some of the challenges around spelling errors. Units. How much does this product cost? 14,000. Is that Korean won, US dollars? Understanding the currencies, understanding temperature. It is often localized. Again, as data scientists, you will often have people at enterprises sending you data from all over the world, not thinking about their unit system is different than the other unit systems that you'll be joining the data with. And then time zones, we already touched on this. So when you have time in your data, when you have dates in your data, you need to think about where that date came from, because it affects how it relates to the other dates in your data. Missing data, very creative. People have very creative ways of encoding something missing. Sometimes it's just a nice 0. Sometimes they'll put 9999. This is a crazy version of missing data, but you can have this. Dates like 1970, 2000. You're lucky when you get things like nan or null. People actually think through and try to encode that the data is missing and not put kind of false data. All right, last topic, and this would have been something if we had more time, we'd actually go through a demo. There was a demo in the previous lecture, and I encourage you to check it out. It's a fun one. Is what to do with missing values. Probably the most common method for dealing with missing values is to ignore the data that has missing values. Why? Because it's easy. In fact, there's built-in functions in pandas to just drop all the rows for which there's a missing value in any of the columns. That's pretty easy. Excuse me. But it has some big consequences. Sometimes when something's missing, that's actually information in itself. Maybe it's missing because it didn't happen at an address. It happened at a place that's not an address. Maybe it has Latin long. The absence of a field like address could indicate a certain kind of data, and just dropping that kind of data could be problematic, right? So think through when you drop stuff, if the absence of data is an important signal. Sometimes a better solution is to keep the data and mark it as missing. So make sure you've encoded as a missing value. You might even create an additional column encoding the fact that this previous column was missing. Third option, and by the way, I will say this is something that I actually recommend most. If you can keep your missing data and work through it, it's a good idea. By keeping it as not a number, things like means and standard deviations will be, you can still run them, but you'll have information about that absence of information. All right, the last technique, which is also pretty common now, is to do some form of imputation or interpolation. The simplest way to impute something missing, what's the student's GPA? I don't have it. Okay. Well, I don't want to drop the student from my records. I could take the average GPA for similar students who are in that major or that program, and just substitute that for now. I should mark that it was missing, so I know that I made a substitution here. But I might use that to do my further clustering, and it won't affect my clustering analysis because I won't have these kind of missing values. All right. Averaging. A pretty trendy technique is actually hot deck imputation. And this is where you take a sample of a similar record. So you're looking for, again, we'll use a student as an example. I'm going to find a student that had similar grades on everything else. And if I didn't have a midterm grade, I could take the midterm grade for that similar student and put it in. Again, I shouldn't do that to make a prediction about that student's grade itself. But if I was trying to analyze the entire class as a whole, that might be a good way to do it, rather than just leaving that student missing. Because perhaps their other grades are important to my analysis, and I don't want to lose that information. There's a variation of this where you can repeatedly resample and then look at how your data changes. And we get to sampling and inference. We'll talk a little bit about that as well, using Bootstrap. All right. And then the last technique, which is actually increasingly popular as well, is regression. So I can use machine learning, predictive modeling to fill in the missing value. Again, this is useful if I want to do downstream analysis over my entire data set. Having that missing value can be very helpful. Good. So multiple imputation is what I just mentioned earlier. So I can resample multiple times from up here. So resample and get a better estimate of what's going on. Okay. Your choice in how you impute the data will affect the downstream statistics and the biases that they present. So imputations will often kind of concentrate towards the mean, certainly if you're replacing things with the mean. You, again, should always be thinking, is the data missing for a reason? Is that absence of data something that I should actually be studying? But I think you have to do that in the homework, actually, so that'll be good. All right, so here's a demo that I didn't have time to do, and we're moving along quickly. So this is the Mauna Loa CO2 modeling demo. It's actually a really fun demo, but I'm going to just tell you the punchlines. There's this sensor that was tracking CO2 levels on Mauna Loa, and it's tracking them every month, so computing a monthly average. And you can see these kind of little bumps, which I'll dive into in a second. And then you get this pretty standard plot for missing values. We have these like big dips. And so what ended up happening is they encoded the missing values as negative 99.9. So that is not the level of CO2 in parts per million. Can't be negative. That is a missing value, right? So I could take one of three strategies here. I could drop those records. So the records are like right here and right here. So I could drop them all together. So I don't have the records in this plot. And when I draw a regression, it kind of looks the same. I could leave them marked as missing. And when I use regression tools, notice how it shows them missing, right? I should not have done that. Yeah, so we don't have missing values here. Or sorry, we don't have values here. So when you're looking at the plot, you know that something is missing, which is why if I'm building a visualization, this is not a bad place to be because it communicates that I didn't have data there. The last strategy is to do interpolation. And here you see we get a better estimate of what happened between these points. And the interpolation method used by the scientists here is actually pretty good. It's in fact so good that they no longer have missing data. When they release the data set itself, they actually fill in the missing values with interpolated predictions. So once you've cleaned your data, removed missing values, you get a trend. You can actually see the kind of monthly patterns. I guess little monthly patterns of the CO2 levels. They rise and fall. And then you can see the overall trend of CO2 rising on the planet. It's a fun data set. Check out the demo. It's pretty short, and you can work with data and do other analyses as well. All right, so wrapping up, EDA. High-level idea. Examine your data and the metadata. That means documentation. What is the date? What is the date, size, organization, structure of data? So we talked through those 5 categories of things to think through. How I do this is I walk from one field at a time. Just go through each of the columns. You know, if I have 10 columns, I'll just check each and make sure I understand the types of those columns and any issues there might be. As you get further along, you'll go, okay, so I understand my columns. Are there relationships between pairs of columns? Here you'll use visualization, which we'll cover next week. So along the way, you'll do lots of visualization, which we haven't presented yet, so we'll do it next week. You're wanting to continually evaluate assumptions you might have about the data, certainly addressing anomalies, and applying transformations and corrections along the way. One last very important point is you should record everything you do. Do not edit the underlying data. Apply transformations in a notebook. Write down why you did those transformations. Someday someone might ask you, perhaps you yourself, how did you come to these conclusions? And you want to be able to explain it. Let's stop here. Are there any questions? No questions. Okay. That is the end of EDA. Now we get to switch to wrangling text, which is often a part of the EDA process, so we haven't entirely left EDA. This lecture will be dedicated to understanding how to work with strings. And this is a topic that's not typically covered in CS curriculum these days, but is very worth knowing when working with real data. All right, so just a snapshot of where we were. We theoretically finished EDA last lecture and just finished it now. We'll look at text today, and then next week we're going to jump into visualization, which will pull all these pieces together. All right, so the goals for today's lecture is we're going to understand the string kind of methods, the operations we can apply in strings, and we're going to learn about regular expressions or RegEx expressions, and how to write them to operate on strings. So we'll start with standard text manipulation tasks. Why am I manipulating text? One common use of text manipulation is to canonicalize your data. In particular, suppose I had these two tables, and I want to join them to get the population for each state, or for each county in each state. What would I join on? What are the primary keys of these tables? Well, I want to join on county. County, that seems pretty obvious. But the problem is these counties don't match, right? So look at these county columns. If I try to join DeWitt with DeWitt County, well, there's a space here and the word county here, right? So the joins are going to fail. And I need a way to make it so that I can successfully join this data by removing these kind of anomalies in how the strings are encoded or written. So that's one reason, canonicalization of your strings. Another reason to work with strings, pretty common, is to extract information for a new column. So here's an example. It's very common that, that log files be a little bit disorganized or just a long string. So this is one very long string right here. And if I just want the day, month, and year, how do I get that from that string? How do I pull out a piece of information? You could also imagine, reading through notes and trying to pull out email addresses or trying to pull out particular mentions of something. So I want to be able to take information out of a string. So that's extraction. Right, so the two main reasons, canonicalization and extraction. Let's go through how to do those today. Confession. When I first started teaching this, I didn't use regular expressions very often. I did most of my work with the pandas string method. It's a really powerful tool that lets you hack away at strings, and I'll demonstrate that in a few minutes. This is probably your first starting point with how you'll work with strings. Regular expressions, which we'll, again, get in more detail, are a much more powerful way to work with strings. But we'll start with the string methods. Right. So you may recall from previous Python experience in Python-oriented classes, or not, I'm going to review it here now. There are operations you can apply to a string. So you take a string, make it lower, make it upper, changing the case. I can replace parts of a string. So I say what I'm looking for and I want to replace. I can split strings, very useful. Split on a comma, for example. Pull a string into a bunch of substrings. I can pull a substring out by just slicing my string. So this is character 1 through 4. So the second character in to the fifth character in the file, or in the string. I can do things like, is this string inside of this other string? So in membership. I can compute the lengths of strings. All of these are really useful, but all of them assume I'm working with strings. But I have a table, and I want to apply these operations to an entire column at once. So pandas has a vectorized version of these operations. A theme in pandas is that I want to try to apply my operation not to elements of a column, but to the entire column at once, so that the system itself, the computer, can very efficiently apply that same operation repeatedly to all the entries in that column, vectorizing. So we have this string operator, a string accessor. So I can take any series. So this is, this could be a data frame like log. Okay, so that's now a series. And I could do something like string, and then some accessor or some method here, a string operation on all the strings in that column. So here's an example. So I'm pulling out of the county, pulling out the county column here. So that's a series, applying the lower operation to make it lowercase. Okay. And likewise, I can do something like replace all the ands with an and, just to make a canonical representation of and. All right, so here are the correspondence. So you have things like lower, upper, replace. They basically directly match. The only difference here is the in becomes contains. So pretty straightforward. You do not need to memorize these. You will look them up as you go through the class. But you should start to be familiar with this idea of using the string accessor to get additional string operations. Demo time. All right, let me zoom in a little bit. See that? OK. All right, so let's do some string manipulation. So here's my two data frames. And remember, in the earlier example, I want to canonicalize these strings so I can join these two tables. So if I don't canonicalize them and I join the tables, I get nothing. Nothing matches. So the merge produces no results. Here is a very long expression to canonicalize a string. So I've defined this function, canonicalize county, which takes a county series. So this will be a series. And then here's a sequence of operations, and I'm taking advantage of the fact that I can break these onto separate lines. So I'm going to convert the counties to all lowercase. I'm going to replace all spaces with nothing, so remove all the spaces. I'm going to replace all ands with and. I'm going to replace all periods with nothing. Sorry, right here, remove all the periods. I'm going to replace county with nothing. I don't want to have county. And I'm going to replace parish with nothing. So I've chained a bunch of operations together. Fire, and there we go. So I applied this function, canonicalize county, to the states counties column and to the population county column. And I get two nearly, in fact, identical strings. So I've canonicalized my strings. If I now do a merge, these two tables together, so I've added my canonical county column. Good practice to add an additional column. I want to keep the original county. Just keep going. I want to keep the original county as is, but I've made a canonicalized version. And now I can join those. And now I can join the two tables, right? Okay, canonicalization. Let's go back. Okay, so canonicalization, done. Let's do very quickly what I would have done before I started teaching this class to extract this information. So data extraction using just these string operations. It's kind of almost a game. So walk through this. So I have this log file. This log file contains 3 lines. Each one of these is a record. So it's my structure. What format is this? Garbage. This is a standard format. When people write logs, they often don't think about you, the poor data scientist. They think about them, the person debugging some piece of code. So they put information that they could read quickly and make sense to them. You have to now extract information from that. I want this information from each of these entries. You could just do something like slicing. So I took the first line, line 0, and then I took characters 20 through 31 to get the date. And that works great for the first line. And I came up with that by hacking at it. I just tried numbers until I got what I roughly needed. But if I applied to the second line, it doesn't work. It's not robust. Better way to do this, let's pull the first line out and take a look more carefully. I'm going to take this line and start splitting it. If I split off this piece, and then I split off this piece, I'll have just the date. And I can keep splitting the dates. Let's do that. So I'm going to split off the first part. So I'm going to drop everything before the square bracket and just take this half. I'm going to split it again on this character right here and drop everything on this side. So 2 splits right here. And everything that's pertinent is stored into the string pertinent. And that's just this piece here. So we keep hacking. What would I split on next? I have it here. That's a bummer. OK. So I want to pull out the date. So if I split, this is kind of cool. Let's just put some separate lines. So I split like this. Okay, so that returns a list, right? I took this thing and split it on commas or on backslashes. I got 26, Jan, and then the date or the time, right? So I can keep this process going and going and splitting until I get all the fields out that I need. You can even pull out the time zone. Cool trick. One thing you hopefully maybe noticed is that this returned 3 things when I ran it here. I can have multi-assignment on the left of my equal sign here. So I say the first thing in the list should be day, month, and then everything else is rest. Easy way to write code. We could do this all with pandas operations. And I'm actually not going to do it, but I've put a solution here. So if you actually want to try it yourself, you can try to do what I just did using pandas as short as possible. All right, questions? I think it'll error. So if you ask to split so the question is if I say split and I assume I have A, B, and C. So I do A, comma, B, comma, C. And then the split finds 1, 2 things, not 3 things. It'll generate an error. You can try it. Yeah, what's the slider question? Can you use str methods in the .apply function? Yes. If you get a series. So str methods, the str accessor, is applied to any time you have a series. Actually, you may clarify that. A series that is either strings or lists. So you can also use the str method to operate on lists. A little more out of scope of this lecture, but we'll see more of that later. Actually, I might have used that trick in my demo. I did here. Okay. Maybe I'll show just that piece. So logs was my my list of strings. If I take here, I'll show you right here. This is my data frame. So I have just this one column, which is my list of strings. If I split on the square brackets, I get a list back, right? And it's actually going to be a series of lists. And then if I use the string accessor again, and I pull the second element in that series, that's the same as taking the second element in the list up here. It's the same as this. I might have confused people. Are there more questions? If this is confusing, it is confusing. When I started doing this stuff, I had to just play with it for a little bit. I really encourage you to go through these notebooks. If something, hey, what if I put in an extra, thing here? Will it break? Yes, it'll break. So you should try it. That is how I learned most of this stuff. Try it. Easiest way to do it. Okay. So I had a demo. You can try to do it. Don't look at my solution yet. Try it yourselves and see if you can do the same thing using string operations. All right, we're going to keep going because I want to make sure we get through everything for your homework. All right. And now for the exciting part of the class, regular expressions. Why is it exciting? We're going to learn a whole new language. Why do we need to learn a whole new language? Well, because doing all this replace and split and stuff, kind of a hack. It can be very confusing. It can be a little bit brittle. And there are situations where it's not enough. I want to find all the examples of moon with as many O's as possible, or as few O's as possible. Any number of O's is fine. Right? That's hard to do with split and replace. So an alternative approach is to use this machinery of regular expressions. And this is implemented in the Python library RE here. You can access it through string accessors. The challenging part of this whole thing is going to be learning this new programming language, which we're going to cover in this lecture here. This is a program in a tiny programming language, which we will now learn. All right, so regular expression basics. So a regular expression, or RegEx, is a sequence of characters. Here's an example of RegEx. This defines a search pattern. So it's a way of searching for something in a string. That's all it does. It is a embedded domain-specific language, which is jargon for a tiny programming language that you use inside of another programming language by writing a little string. So let's do our first program. This is the string that matches social security numbers. For those who aren't familiar, a social security number is a sequence of numbers that's used often in the United States to track various parts of employment and all sorts of things provided by the Social Security Office. And it is a sequence of 3 digits, followed by 2 digits, or followed by a little hyphen, followed by two digits, and then another hyphen, and then 4 more digits. And to encode that, I use this string that says a number between 0 and 9 3 times, and between 0 and 9 2 times, and between 0 and 9 4 times. That shouldn't make sense to you because I haven't explained it, but that is an example. In the remainder of this lecture, this will become very obvious what I'm doing here. All right, one important note. How do you pronounce RegEx? RegEx. This is actually still debated. RegEx should be pronounced RegEx. The G is in regular. And if you would like to pronounce it RegEx, then it's the G as in regular. So RegEx should be a soft G. It's a portmanteau of regular expression. Okay. Cool. Fun video. All right, let's do one important thing. Again, this is about to get a little confusing because regular expressions are, they're hard to read. Your goals for today is not to memorize everything I'm about to tell you, but to understand the big ideas. How I would write a regular expression with a reference table. I need a reference table. I do a lot with regular expressions. I still go find a reference table before I do anything. So it's okay to have to look stuff up. Even when you do this in the exam, we're going to give you a reference table. It's knowing how these pieces work together. So high level. All these weird things we're going to go through today, you will learn in practice in time. When learning regular expressions, it is helpful to use this tool. I actually use this tool when I'm building new regular expressions. It's a nice website. It's very easy to use. You can write a regular expression here. You can write some practice strings down here, and it'll tell you, did it match? And it'll even give you an explanation over here what's going on. But if you use this, it's very important that you turn on the Python flavor, because guess what? There is more than one version of regular expressions. We're going to focus on the Python one in this class. It is pretty standard. Okay. If you want to learn a lot more, you can go here. This is a long description of regular expressions that comes with Python. It will tell you much more than you need to know for this class. But if you want to become an expert in these kinds of transformations techniques, this is worth looking at. Fernando made an important note here. So when you see this on websites, this little thing here, it allows you to suppress this stuff so you can easily copy and paste just this part and then try it in a cell yourself. So again, repeated guidance. The best way to learn a lot of this stuff in this class is go try it. Open up a notebook, play with it. It'll become way more obvious when you play with stuff. All right, here we go, the basics. This is the first and easiest part of regular expressions. The consecutive sequence of characters here, A, B, A, or start with this sequence of characters matches this and only this. So if you do Control F in your, pick your favorite program, you're doing this concatenation. You put a sequence of characters, you find exact matches of that sequence of characters. New syntax. The or. That's an or. So this expression here, this string, AA or B, AAB, matches, get this, AA or B, AAB. Everyone's with me so far. This one's not so bad. So I can match this or that with the or. And now we get to something more interesting. This is the star. This A, B, star, A matches 0 more instances of the thing immediately to the left of this guy. Right? So that matches AA because there's an A and then 0 B's and then an A. It matches ABA because there's an A and 1 B. It matches ABBA. It matches any number of B's as long as it's followed then by an A. So A, as many B's as you like, and then an A. And we'll one more piece of syntax, parentheses, just like the parentheses you know already. So see how this immediately applied just to the B? I can now write this, A parentheses AB, close parentheses, star A will match just A, which means 0 of this thing in parentheses, or ABA, or ABABA, and so on. Yes. So this star applies to whatever to its left. And there's an order of operations, which I'll explain on another slide. In this case, the precedence is for this concatenation. And so this B is all that it's going to replicate. So the star says B 0 or more times. So it can take an A followed by 0 or more B's followed by an A. So an A with 0 B's, an A with 1 B, A with 0 B's, A with 1 B, A with 2 B's, and so on. These things are called meta characters. They are a core part of our new programming language. And these things here are just called characters. They are the things we're expressing in our strings. Yes? It'll work with lowercase, uppercase. We're going to get into a whole lot more. We're just starting. Okay, so I said something about order of operations. So there's an ordering of operations. Grouping has the highest priority. So the group creates essentially a thing. But before anything else is applied, I group what's, I apply the grouping. The next thing that applies is the star. So the star then applies immediately to its thing to its left, right? And then concatenation, right? And that's why when I did A, B, star, A, this star applies here because it's higher precedence than concatenation. Okay? So if I want it to be the whole thing, I have to put parentheses around it. Now it's the whole thing. Okay? And then or is last. Or. So I get the whole expression here, and then or the whole expression here. It's not the or of these two things, for example. Okay, I think there's a Slido. So let's do some practice. So which regex pattern will match the string ABBA? We should change this Slido, which is on the table. I apologize. Last time I didn't leave the slide up long enough for people to fill it out. Hopefully everyone's had a chance to fill it out. Good. We did that a lot, so you're getting it. Let's walk through it. So A, B, B, A is matched by, this is the correct answer, A, and then 0 or more B's. So this is 2 B's followed by an A. This is just a string. It'll only match A, A, B, B, A, B, A, B, A, B. This, remember the order of operations, this means I have to have A, B, A, B. It has to match that group, that A, B group has to be repeated. So it can be, oh, leave it alone. And then this last one is either AA or BAA, B. So that also does not match ABBA. All right, hopefully everyone's had a chance to fill this out. 538, 541, go, go, go. Submit something. Questions? All right. More practice with star. I think there's one more Slido. Let's do the other Slido, and then we'll do some more star. Again, if this is confusing, that's okay. It is confusing. You'll need to practice it. We're just getting the intuition. All right, so more star practice. Which pattern matches moon, moon, an even number of O's? Any even number of O's except 0. Don't match MN. All right, let's see what people said. Okay, let's walk through it. So the first one here, again, is the right answer. Why? So here's how I read it. The string has to begin with M, or the thing that matches begins with M, followed by 2 O's, followed by, here's a group, 0 or more copies. Oh, no. Clicked, sorry. 0 or more copies of this OO pair, followed by an N. So the star says whatever is to the left of it, and if it was just a character, it would be that character, but here it's a parentheses, so it's the whole group, can appear 0 or more times, and then that string will match. We're going to get more practice because we're going to add more symbols. We'll see how they start to interact. Keep going. Let's actually, I'm doing on time. Let's try one of these. Maybe we have time for one of them. I'm going to go to this guy here. Turn off my pen for a second. All right. So I want to match moon, or I want to match an even, basically the same thing as before, but either O's or U's. How would I do that? So I want an M. And then I want what? Double O. And then maybe I'll put a parentheses for another, oops, sorry. Double O star. It's one thing. Or, did I get this right or wrong? I want a UU followed by 0 more copies of my UU. So that didn't work. Why did that work? Because it's saying I want this or this. You guys can't see that clearly. It's saying, remember the order of operations is this whole expression on the left or this whole expression on the right. So if I want to change that order of operations, I put a parentheses here and here, I get it. So let's try to parse this once more. So that I want 00 followed by 0 more copies of 00, or UU followed by 0 more copies of UU, and I want this whole expression between an M and an N. Now, if I remove these parentheses, I'm going to match moo and but not moon or mun. Okay. Try it. Just play with these things. It's the easiest way to learn this stuff. I wish it was better I could just teach it, but yeah, this one you have to just try. Okay. All right, so new characters. Period. Look for any character. That's what period means. So it matches any character. So dot u could be cumulus or jugulum. Where are brackets? This creates a character class. So this expression here means any character that is between capital A and capital Z, or little a and little z. So this is a range right here. This is another range right here. So this matches A, B. It only matches one character. Let's go away again. So this is matching, this defines a character as anything in that range. I could also add, let's just do this. I could say a Z, and maybe I do a Z, and then 0, 9. That's all little and lower, or all little letters, big letters, and numbers between 0 and 9. Plus. Plus is star's cousin. Plus matches one or more. It's just like star, but one or more, which would have made our earlier examples much easier, right? So star is 0 more copies of the thing to the left of it. Plus is 1 or more copies of the thing to the left of it. So this here will not match A. Whereas if this was a star, A, B star, it would match A. Okay. One more close cousin of the star and the plus, or the star and the plus is the question mark. So this matches 0, 1. So it's saying A and B is optional. All right, almost last set of syntax. Squiggly brackets means repeated 2 times, so repeated X times. So if I have A, B, and then squiggly brackets, again, it applies directly to the B. So B must occur twice. And I can actually do a range. So squiggly brackets with the range. So A and then B can occur anything between 0 and 2 times. Ranges are inclusive here. I feel like I'm just telling you syntax, which is never fun, but you have to have an intuition for this. You'll get a big table that explains the syntax, but you should be able to think through what I'm saying here, and sort of having this in front of you, be able to apply it. All right, I'm not going with these details, but you can use these ranges with slicing. So you say 0 to forever, 1 to forever corresponds to these same operations. Yeah, I won't explain that more. Okay, so we've talked about the basic sets. Let me dive into character class a little bit more. So this defines, again, all the letters, all the capital letters. This would say all the numbers 0 to 9. And this is all letters, capital and lowercase, as well as numbers. Because we do these things so often, there's built-in syntax for those. So /W, this guy here, is equivalent to this thing here. And then here, /D, this is equivalent to the digits here. And then this here is matching any kind of white space. That could be a tab, a space, white space characters. Some more syntax. One last little bit of syntax here. If I put this caret, so if I do this right here, this is saying any character that's not a capital letter between A and Z. So it's negation of whatever comes to the right, whatever is inside this box. All right, so summary so far. So we've talked about any character. We've talked about character classes. We've talked about using the squiggly brackets for repeated and repeated ranges. So that. And then we talked about the at least one, the plus character. We got one more demo, one more Slido. While this Slido is going, questions? Yep. I think or has the lowest priority. I can't think of any other characters that have lower priority. I could be wrong. The regular expression full syntax is pretty big. What we cover in this class, or I think has the lowest priority. All this stuff. All right, so choose a cleaner solution to the example from before. Which pattern matches moon or moon? 6, come on, fill it out. And I think I want to match any number of O's that are even. Example. What would this match? Now let's see what we got. Okay, people are getting it. So MOO plus means one or more copies. So moon, moon, and then moon, as long as it's a even number of O's. This matches moon, which is good, but not all number of O's, all even numbers of O's. What does this match? Quite a bit, right? Well, I guess moo, and then any character you want right here, be fine. Okay. One more. All right, what pattern matches any lowercase alphabetic string that has a repeated vowel? So noon, heel, festoon, loop, oodles. Which one? All right, so I want to think through this. Let's start with the first one. So dot means anything. Star means 0 more times. Square brackets is a character class. It says any vowel, so that character class is all the vowels, has to occur once or more, followed by any number of characters afterwards, 0 more of anything. Okay. I have one here. All right. So people are starting to get it. So the first one is correct, and we'll come back to why the second one is incorrect. But the first one's correct because it's saying, I want any lowercase character. I guess I should have said that. Oh, no, we just said any lowercase character, repeated 0 more times, followed by this group. And this group, oh, I can't click. Okay, sorry. It should be reopened, I think. This group says AA. Remember, order of operations, or is last. So it's AA, or EE, or II, or OO, or UU. So something from one element in this or, followed by a lowercase letter repeated 0 more times. That's what we're looking for. It's lowercase alphabetic string. So noon works. So N fits here, and then OO would match here, and then N matches here. Festoon, same thing. Oodles, there's 0 here, so it just goes straight to OO, and then repeated characters here. So DLES. So this didn't work because we said any character, that could be uppercase too, so that's the problem, repeated 0 more times, followed by a vowel, repeated 1 or more times. So a vowel once or more. So A would have been a valid match, and we needed repeated patterns. So it need to be at least 2, and I think we wanted an even number. No, it needed to be at least 2. So this was at least 1, and then any character at the end. Questions? Yeah. How do you get brackets and parentheses? That's a great question. I think that might be my next slide. No. Okay, we're going to come back to that soon. Suppose I want to match a brackets and parentheses. There's a way to do it. Before I get there, I want to talk about greediness. So greediness in the context of regular expressions. And maybe actually this one is best done with an example. So if I have this regular expression here, so I have div followed by any character repeated 0 more times, followed by div. These are all valid characters. What would that match in this string here? This string here. Where'd it go? I think my goal might be, I suppose I want to pull out all of these things. I want to match this and this. What will this expression match? So let's try it. I've got this expression. I've got the text down here. So I put this expression in. It's greedy. So it goes, okay, so I'm looking for div. I got div right here. And now I'm going to try to match 0 more characters as long as I can. So match, 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 match. Still matching, still matching. I'm going to keep going until I get to the very end. And then if I say now I can match this closed div, that's the end of my expression. It's greedy. It just keeps going until it can't go. We want to sort of look ahead and say, okay, can I close it here? Stop going. So we can put a question mark here. All of a sudden, it's not greedy as well. I'm going to go until I get something that matches the rest of my expression. A little confusing. Let's get rid of that again. So this is saying, I see div, and I just keep going. Everything, this is a dot, this is a dot, this is a dot. All these are valid dot. They're just any character. And it says, sorry, match any character 0 more times until you can't. But in this case, it means until I can't finish this expression, right? So I want to end on a div, but this will eat this div in the middle. This dot star just keeps going. Very confusing. Yeah. Great question. So when I add the question mark, isn't that redundant? That's all right. So when designing this programming language, which many of you might be saying, this is the weirdest programming language I've ever seen. You are correct. There would be no reason to have a question mark after a star. And so they use the question mark after a star character to indicate don't be greedy. So that's a special syntax in language. So when you follow a star and only a star with the question mark, it makes the star not greedy. Star and a plus. So any of these repeated matching characters. Or repeated matching operators. That's an operator, and this is an operator on that operator. So question mark is operating on the star here. Sorry, this is confusing. I wish regular expressions were easier. That's what it is. You got to practice it. All right, let me see if I can give some more explanation. So the idea here is in English, the expression is going to look for div, which it finds. It finds. Oops, sorry. There's the back one. So yeah, it's going to look for the div character or div, this expression here. So it's looking for div, and then it's going to look for any character 0 more times. It goes, oh, any, these are all matching. Technically, this matches, but then it can't terminate the expression. So it'll never get to match div. So then backtracks and goes, okay, so it goes here and then stops here. And if I want it to stop here, I needed this question mark to make it not greedy. All right, the last set of rules, and then I'll do some code and we'll be done. Almost there. Okay, read the next character literally. Someone asked before, how do I write slash? or sorry, slash will come back to in a second. How would I write parentheses? I want the parentheses character. Well, you do a slash parentheses. So treat that character not as an operator, a meta character in my language, but as just a vanilla character. You want a plus, do slash plus. So that's right here. Okay. We just told you caret was not. Well, that's not true. Sometimes caret's not. So when you put caret like this in a character class, when defining a character, this means not A or B, right? Can't be the character A or B. But when you put it at the beginning of an expression like this, not inside of square brackets, that's saying I want to match from the very beginning of the string. So I want to start at the beginning of the line, and I can only find things that match starting at the beginning of the line with this character stuck in the beginning of the line. So this will match ABC. So this would match ABC 1, 2, 3, but it will not match 1, 2, 3 ABC. Okay, so it would match here, but will not match here. Won't match here. Okay. Be careful, as I said before, different meaning when this is inside of square brackets. All right, and then the last goofy character, the $sign. The $sign is just like the caret, but for the end of the string. So this says that the string has to end on this $sign. So this only match ABC if it's at the very end of a line. Or end of a string, sorry. Okay. So I think we've covered all the syntax. You will get practice with this on the exams, and when you do assignments, you should look at tables because it's hard to remember all this stuff. I have to look it up each time too. So we talked about beginning of line, carets. We've talked about end of line, $sign, and then the escape character here will let you turn any of the special characters into just regular characters in your expression. All right, brief interlude, which I'm going to do really briefly because I want to get to how to use the code. Regular expressions can be, as you've already seen, painful. Here is the regular expression to match an email. So writing these things and reading these things is very hard. There's a joke that these are write once expressions because after you've written your own regular expression, it's often hard to figure out what you were trying to do with that expression. So it's a little bit painful, but they are very fast for processing strings, and they can do pretty sophisticated things with strings. All right, so now I need to cover the functions to actually use these in code so you can do your homework. So the first thing you need to know about is raw strings. So this is, you basically put an R at the beginning of your string in Python. You can choose your favorite quote character. And that means I interpret the string as is. What does that mean? So if I put a /n in a, I put a /n in a string, Python sees this and goes, you mean a new line character, and it replaces that with an actual new line character, which is not on your keyboard or not easy to put in a string. If you make it a raw string, it doesn't do anything to your string. It just leaves it as is. So you can put funny characters in your string, and it will not try to modify them. That's important when you're writing regular expressions, which is full of funny characters. Okay. Let's see if there's an example. Yeah, so we'll do some examples in code, but if I didn't use this R, in order to put a slash in my string, I'd have to put a slash followed by a slash, because I got to tell Python that this slash is not a Python slash, but a slash slash. So you end up with these huge numbers of slashes in your strings. So R at the beginning of all your strings, first thing to know. All right, so now the regular expression library, RE, has a simple string operation, find all, which takes a pattern and some text. It'll find all the occurrences of that pattern. So if I take, this is my text here, this is long string, and this is my pattern. And we already saw this pattern before. So it's a number repeated 3 times, and a dash, a number repeated 2 times, and so on. I will find this pattern in this text. When I say find all, it returns all the substrings that match this pattern as a list. So these are all the substrings that match the pattern. Okay. This operation here was on a string. You can do the same thing with the series. So if I have a series of strings, I can take whatever my series is. So let's say my social security number strings, and I can say string dot find all, and then give it this pattern right here, stick it right here, and that will find all the social security numbers in my string. So return for this is my table right here. will return this table, or this series, where in the first row I found 1, in the next row I found none, in the third row here, row number 2, I found 2, and so on. So it lets me extract stuff from each of my rows. Vectorized. Demo. Let's do it really quickly. I'm going to make it. Okay. Regular expressions. So we just described, here's my text. This is exactly the thing on the slide, so I won't explain it again. Key point here is I imported the regular expression library RE. Same thing on a data frame. This time I don't need to import the library, so I have my data frame of social security numbers. Don't know whose social security numbers these are. Probably some faculty at some point. And I'm going to apply this pattern. Notice I said R. It's a raw string. So I want to apply this as is to the social security number column. So I'll take the string accessor, apply the string method find all with this pattern. What do I get? I get a list. I get a series of lists, just as I showed on the slide. Suppose I wanted to get the last element from this series. So I just want the last social security number from each line. So I could take the string, I do find all again, and now I use a string accessor again. And remember, it works on lists, so I can get the last element from each of those, which would look like this. -1 gives me the last thing in the list. All right, play with this code. It probably doesn't make sense. That's okay. Work with it. Try changing it, see what happens. Maybe put a 0 in here. What does that do? And 2. Fails. So play with the code, try to understand what's going on. That's the easiest way to learn this. So we do these demos. Okay, almost there. Capture groups, last big idea. So remember I told you parentheses, they group stuff? Just organize your regular expression. They do a little bit more. When you put parentheses around stuff, it defines a capture group, which means you pull out not just the whole string, but also that little piece. And you can use these regular expressions to actually match multiple things at once. So very useful for extraction. So here's an example. Suppose I want to pull out the hour, the minute, and the second from this string. So these parentheses here aren't necessary. I don't need these parentheses, but I've added it. If I'd removed it, it would match this regular expression, would still match the whole string, in fact. If I delete this here, this regular expression would match this thing. So it would extract that thing. But I actually want to extract it in 3 separate parts. So by putting parentheses around the pairs of digits, this says digit, digit. So I want this pattern will match anything followed by digit, digit, colon, digit, digit, colon, digit, digit. And these parentheses say pull out these 3 pieces from that regular expression. So that will extract a little tuple, which has the 3 strings pulled out as separate parts. That's how you pull out little pieces of a string. Very useful when you're trying to pull out parts of a date, for example. So this is capture groups. Let's try this, actually. So I'm going to use the capture groups system to extract multiple columns from each of these examples. So I'm going to extract capture groups. So just to demonstrate this again, we should put an R here. That's raw. Okay, so this string is the string that my pattern that I showed you earlier. Applied to this string here, we'll pull out these 3 fields. Okay, we can apply that to a series. Let's do it down here. So now I have this social security number table with 1 column in it. This column contains strings, and I want to pull out each of the parts of the social security number as separate columns so I can work with them separately. So now I'm going to go back to my earlier social security number example, and I've added these seemingly unnecessary parentheses. Bigger. So I didn't need these parentheses, but I'm defining capture groups by creating them. And then when I extract from that social security number column, I use a string extract method, it's going to pull out separate columns for each of them. It's very convenient for pulling out pieces of data from a long string. But one thing I wanted to show, so when I'm working with this and I can't figure stuff out, I like to use the Shift-Tab way of getting documentation. The problem is, if I do that here, it doesn't work. It doesn't work because this thing is not evaluated yet. So it doesn't know what method this is going to be. I can't read that just from looking at the code because you have to actually run this piece of code. So it produces something that I then take the string accessor for. So a little trick, if you want to work with series, is save the series to a variable. So I save this series. This is series, this variable here. This variable now has a type. I know what it is. And the string accessor can be used to access that string. Now, when I go over here and I say extract, and I hit Shift Tab, it shows me the documentation for it. So when you're debugging stuff, you're like, why is this not working? This is a standard trick. Just save your series to a single variable and then start playing with it as a single variable. We're almost there. Extract all. So this will allow me to find multiple occurrences in the same row. So remember, one of these rows had 2 social security numbers. When I say extract all, it creates 2 rows. So row 2 has match 0 and match 1 broken out into separate rows. This stuff is super useful when you're trying to pull out lots of information. Let's say you have correspondence from people or a Slack message and you're trying to find all the email addresses. Some message might have more than one. You want to be able to pull them out into separate pieces. We were talking about extraction. Remember we talked about canonicalization. A key trick in canonicalization is often just finding parts of a string and deleting them. And you can use regular expressions for this as well, deleting or transforming. So here, I can take the regular expression library, I give you a pattern, and I say wherever something matches that pattern, replace it with that other piece of text. Okay. So common use, I've actually used this before, is I want to remove all of the HTML tags from a string, and I just want the text. We can do that. So this defines a regular expression, which is going to remove all of the HTML tags. This matches an HTML tag. And I say, take that pattern and replace anything that matches the HTML tag with a single character, or with no character, with a blank. Delete it. Once more. Actually, let's look at this expression. What is this saying? This is saying I want to match a bracket followed by a character class. This is a character class, which is not a closed bracket, 1 or more times. So I need 1 or more characters that are not a closed bracket, followed by a closed bracket. You should play with this particular piece of syntax. This is a way of getting around the greediness problem. So this is matching everything that's not this. Once it hits a closing bracket, it'll end this regular expression. And that'll be a match. And anything that matches, like div, it will convert to nothing. So it'll delete div and td and so on. So it deletes all of my HTML tags. So I get back just a very clean string, which is raw text. All right. What I told you how to do this for the single string. So this takes a single string, just a Python string. As recurring theme in this class, if I have a series, I take the string accessor, I run the same function. It'll do the same thing. Here, I think you need to say regex equals true. Regex equals true. Otherwise, it'll just assume you mean a vanilla string matching. So this does exactly the same thing. So this is the same as this, but on a data frame, on a series. So I can take a series of HTML. So each of these things is a piece of HTML. And I can just delete everything that's HTML about this string. So deleting all of this stuff by replacing it with nothing. All right, so quick summary. We covered all of these functions now. These are the base Python functions. These are the regular expression functions in the regular expression library here. And then here, the thing you'll use most in this class is this stuff over here. And in general, for your assignments, focus on using these pieces here, unless we say otherwise. Okay. This slide has a star in it, which I didn't add there. So I assume this is a slide you should memorize, or maybe it's something you should study for the exam. But this is the basic piece of Python syntax you need to use regular expressions. Okay. We're almost out of time, which is great because I am almost done. I apologize, regular expressions aren't the most exciting topic, but you should practice them. They're fun to use. And I think there's some links actually to some games where you can try writing regular expressions to hit certain targets. So it can be fun if you start playing with it. I said this earlier, regular expressions are a little hard to use. They're a write-only language in some sense. It's hard to read a regular expression. You have to kind of think through it. They're still very powerful. The other thing that is worth knowing is they're also very fast. So if you're processing large amounts of data, regular expressions are often the best way to pull out key piece of information from that data. But of course, they can be difficult to debug, difficult to read, and you have to learn the syntax in order to use them, or at least have a table right beside you. Worth noting, there are situations where you should not use regular expressions. There's Python libraries for working with HTML. You can delete HTML using regular expressions, that's fine. But if you're actually trying to find important piece of information from an HTML document, an XML document, JSON, don't write your own regular expressions. Use the Python libraries for working with that kind of data. If you don't know what those libraries are, you can Google them. We've already covered a few, like the JSON library. If you're working with HTML, there's things like Beautiful Soup that make working with these things much easier, so you don't need to write regular expressions. Okay. So it's still a limited language. All right, so that is it. We actually finished on time. That is text wrangling. You'll have plenty of practice. Next week, we'll have much more fun with data visualization.